you got lucky, you could play with numbers and you could figure out that 2 cubed times 3 cubed times 5 squared is 8 times 27 times 25, which gives you 5,400. And 5,400 is indeed between 5,000 and 6,000, and x plus y plus z is 8. So if you're trusting that this problem has just one solution, you could have found it. It's 8, and you'd be done. Whether you would stumble upon this specific example quickly, though, I don't know. Not that the method that I'm going to show you is going to be very quick either. I feel like I'm missing a more elegant solution, but here we go. So I'm going to try to get x plus y plus z within a certain range, because I know that if I add these up, like, they can't be that big, otherwise we're going to exceed 6,000. And they can't be that small, otherwise we're not going to make it to 5,000. So we're going to look at the extreme cases. What if we maximize the use of our smallest number, that'll maximize the value of x plus y plus z. That'll make that biggest. So if you look at powers of 2, I'm going to jump. I know that 2 to the 5th is 32, and we don't have a calculator on the test, but it's not too terrible to multiply by 2's. 2 to the 8 is 256. Multiplying that by 2, we get 512. And you can actually stop there because you know that y and z have to be at least 1. So you're going to be multiplying 2 to the x times at least 15. So 512 times 15, that's more than 10. It's going to be bigger than 6,000. So I know that 2 to the 9th times 3 to the 1st times 5 to the 1st is already greater than 6,000. So the most I can have for x plus y plus z is 9 plus 1 plus 1 is 11. So x plus y plus z, those exponents put together can't be any bigger than 11 because that's the most amount of 2's that I could possibly use. Alright? So you can kind of eliminate these guys here based on that. The 11 cuts it close, but it certainly couldn't be 18. Because if you had like 18, then this would be 2 to the 16 at least, and 2 to the 16 would just be ginormous, and there's no way that it'd be less than 6,000. So now, to get it between those two, you look at the other extreme. The smallest the exponents could be would be if you maximize the use of your biggest prime. So if you look at powers of 5, I know 5 squared is 25, 5 cubed is 125, 5 to the 4th is 625, and I actually know that I think I can stop there because I know that 2 to the 1st times 3 to the 1st, because we're going to have at least one of those, is 6 times 625, and 6 times 625 is less than 5,000, but if you go one more, you're already greater than 5,000. So the least amount you could possibly have would be 1 plus 1 plus 4 is 6. So x plus y plus z have to be trapped between 6 and 11. Certainly couldn't be 5, because if you were 5, you couldn't make it up. If it were only 5, you couldn't make it up to 6,000, not even if you made it 5 to the 3rd times 2 to the 1st times 2 to the 2nd. That's not big enough. So we kind of hopefully figured out kind of a range, and elimination, because it's a multiple choice problem, makes it easier. We do see that x plus y plus z could possibly be 8. We even have an exact example where x plus y plus z, 3 plus 3 plus 2 could be 8. And that will put our number in the right range. Kind of annoying, but we made it, so yes.